By the way, this is a special equation I've picked. It's known as Clairaut's equation. And the equation is this. It's y equals x dy dx minus dy dx squared. Clairaut's equation is any equation which has the form y equals x times dy dx plus something which depends only on dy dx. In other words, rather than write this in an abstract form, I decided to pick a particular application of this, and that is, let's just pick this particular example. That's one special form of Clairaut's equation. That's what y equals x dy dx minus dy dx squared. X times dy dx, and what's left is a function of dy dx alone. At any rate, it turns out that one explicit solution of Clairaut's equation, a very interesting thing, is you simply replace dy dx by c. Very amazing thing. In other words, if you have a Clairaut's equation and you want a solution, every place you see dy dx, replace it by c. For example, in this case, I would get what? Y is equal to xc, or cx, I guess you like to write the constant first, cx minus c squared, which, by the way, is what? A straight line whose slope is c and whose y-intercept is minus c squared. By the way, the proof that this is a solution is simply differentiate this. You get that dy dx equals c. Since c is dy dx, every place you see a c, replace it by dy dx, and that will give you what? Y equals x dy dx minus dy dx squared. I'll give you more on that in the exercises on how one solves Clairaut's equations. I want it for illustrative purposes here. So anyway, this is a solution of this particular equation, and it's only one solution. I don't know if there are other solutions or what have you. The next question that I would investigate here, just as in the previous case, I would say, gee,